restrictions on pretty much all the questions that we do from now on, because you're going to have variables in the denominators. Some of these are going to be expressions, some of them are going to be equations. We're going to spend kind of a few more days on expressions. So we're not solving for x or anything like that. We're just going to simplify these expressions today. But restrictions, basically what you have to remember is you can't divide by 0. So basically your restriction is going to be to exclude anything that makes the denominator, doesn't matter about the numerator, but the denominator, so the bottom of the fraction, anything that would make the denominator equal to 0. Okay, now the most challenging thing, I think, for all of these questions is people look at these problems and they go, oh, there's an x here and an x here, and they just cross them out. And it does not work that way. You have to put these guys in factored form. If you have adding or subtracting, like this, don't write this on your paper, but this first thing, this is really like 4x over 3x plus 15 plus 20 over 3x plus 15. So you can't just cross stuff out, all right? It does not work that way. What you want to do is see if you can factor anything. So that's going to be the major goal for every single part of every single fraction today, is see if you can take and factor it. If you can put it in factored form, then you are allowed to cancel things out. Don't write this on your paper either. Let me make something up. I don't know. So like, let's say I had 15 over 20. This, you would not do this here. You would just reduce this fraction. But this is the same thing as 5 times 3. This is the same thing as 5 times 4. I can cross the 5's out because that's being multiplied, and then I would have 3/4 as my answer. You guys would probably just reduce that, but it works like that with the variables. You have to put it in factored form where you're multiplying two things together. If they match, then you can cross it out. Okay, so the very first problem we have here is not quadratic. It's just like 4x plus 20. So what do 4x and 20 both have in common? 4, right? What would be left if I took a 4 out of both of those terms? X and 5. So it'd be like this. So I know this is a product now, right? I have 4 times this x plus 5. Okay, on the bottom, what do 3x and 15 have in common? 3. What would be left if you divided 3 out? X and 5. Okay, now here's the deal. I'm multiplying two things on the top. I'm multiplying two things on the bottom. If they match, which they do here, they're both an x plus 5, then you can cross it out. And this would reduce to 4/3. It doesn't always happen. Sometimes you have variables left, but in this particular problem, that cancels out as long as they match and as long as it's in the format where you're multiplying things together. So I'm multiplying 4 times that x plus 5, 3 times that x plus 5. Then you can cross it out. Now, this is the tricky part though. Even though I crossed that out, there is a restriction there. Can anybody tell me what, I'm going to say x can't be equal to, what would cause my denominator, what number would cause my denominator to be 0? Like before I cross those out. Not 5. Close. Like what would I plug into x plus 5 to make that 0? -5. I know that, and even though this crossed out, it's part of your restrictions, -5 would be a problem for that denominator. It's whatever would set it equal to 0. So if you're not sure, I could actually take it from the original problem. Do like 3x plus 15, I do not want that to be equal to 0. You'd subtract 15, divide by 3, or you could do it right here, just the x plus 5. I don't want that to be equal to 0. That's your restriction. So this, with my restriction, would be my answer. Does anybody have a question? Okay. So we're just going to try and factor this. So I have x squared plus 6x on the top. So just looking at the top, what do x squared and 6x have in common? X. All right, what would be left if I took an x out? X plus 6. Good deal. Okay, now I don't know, we haven't done this for a long time. Do you guys, the bottom of that's called a difference of squares. So it's quadratic. So I would want to look for two numbers there that would multiply to get negative 36 and add to get nothing, because there's no middle term. Yes, so the factored form in the bottom of this, just one of them's x plus 6, one of them's x minus 6. It doesn't matter which one you write first or second. And then once I'm multiplying two things on the top, I'm multiplying two things on the bottom. We're just looking for anything that matches. Anything that matches we can cross out. So the x plus 6's match. So on the top, you would have x. On the bottom, you'd have x minus 6. You cannot cross the x's out because that x minus 6, you'd have to have something that matched that on the top. I don't have anything that matches that on the top. Do not cross the x's out here. This would be your answer. That's as far as you could go. Okay, now I have to go back here. Anything that would make my denominator 0, even if we crossed it out, we have to exclude. So like even though we cross this out, negative 6 would cause that to be 0, positive 6 would cause that to be 0. So I have two restrictions here. X can't be, and if you want to just write it like this, plus or minus 6. It can't be 6 or negative 6. There's two restrictions there. Is anybody having a question? Okay, each one of these is just a hair different. So I can't even factor the top. The top of that's just one term, right? It's just 5x. So nothing to do on the top. Could you do anything with the bottom of this fraction in terms of factoring anything? Oh, he's already got it. All right, 5x, what would you have left? Perfect, 2x plus 3. So all I'm doing, if you're like, what the heck, where are we coming up with this? I'm taking both of these terms, dividing them by 5x. It's like undoing a distributive property, pulling it out in front. 10 divided by 5 is where the 2 comes from. X squared, you're going to take an x out, so you have one x left. 15 divided by 5 is the 3, and then the x's here would just cancel, so it's just a 3. Now, on the top, I just have a product, right? I have 5 times x. On the bottom, I have a product. I have 5x and then the 2x plus 3. So this 5 and this x cancel each other out. What would you leave on the top? 1, because it exists, so we don't want to put 0. Now, on the bottom, I would have 2x plus 3. Okay, now for my restrictions here. 5 times x can't be equal to 0, right? That was one of the little pieces that crossed out. What would you plug in for x there that would make that equation? Like what value would we plug in for x here? 0. So here, 0 is going to be your restriction. Okay, now the other one, now I don't usually do this, but I want to show you this. I don't want that 2x plus 3 to be equal to 0. So what I usually do, I literally just think to myself, okay, I have 2x plus 3, how would I do that? And I'd say, okay, I would subtract 3, divide by 2. So I don't usually write this out, but you would subtract 3 here, and you would divide by 2. So your other restriction, we don't want x to be negative 3 over 2. So this one has two restrictions. X can't be 0, and it can't be negative 3 over 2. So even if you cancel it out, you have to restrict it because it would make the original problem equal, or divide by 0, which you can't do. All right, let's see this guy. Now, the top of this, all I'm going to do is see if I can find a greatest common factor between 3 and 6. Can you guys think of anything 3 and 6 have in common? 3. All right, so if I take a 3 out, what would you have left? Perfect. Okay, now the other one's kind of like a more traditional quadratic. So if I just look at the denominator here, I would want to find two numbers that multiply to give me positive 8, same two numbers add to get me negative 6. Can you think of two numbers that do that? Good deal, negative 2, negative 4. So one x minus 2, one of them x minus 4. It doesn't matter which one you write first or second. Then all you're looking for, I have a product on the top, 3 times that x minus 2. On the bottom, x minus 2 times x minus 4. We're just looking to see if anything matches, which I have an x minus 2 on the top, x minus 2 on the bottom. So those go away. My actual answer, we'd still have a 3 on the top, x minus 4 on the bottom. Nothing else cancels or anything there. And your restrictions, right here, 2 would cause you a problem and 4 would cause you a problem. That would make the denominator 0. So x can't be 2 or 4. Those would be my two restrictions. Some of these have one restriction, some of them have two, some of them might have more than that. Is anybody having a question? Okay. Now, the one at the bottom, this is probably the worst because the top of that has a number in front of the x squared. So let me just see if you guys could factor the bottom of this real quick, and then I'll do something to the side. So just looking at the bottom, all right, I just have an x squared minus 11x plus 18. So I would want to multiply to get 18, add to get negative 11. Yes, yes. Okay, so x minus 9, x minus 2. That's your factored form. Okay, now, a lot of different teachers teach this different ways. Did you guys, I usually do the Berry method. Did you guys do like factor by grouping, or what did, I've got this 2x squared minus 3x minus 2. I'm going to try to factor that. You only have to do like kind of a different process, I think, if you got a number in front of the x squared. I'm going to show you the Berry method if you haven't seen that before. Okay, now in the general form here, you've got ax squared plus bx plus c. That's the general form of a quadratic. So you take the two numbers, you multiply a and c. That previous question, it was just 1 and 18 because I didn't have anything in front of the x squared, so it would just be a 1 for my a value. Here, if you got a number in front, I'm just doing first times last, a times c, so it would be 2 times negative 2, which would be negative 4. And then you always add to get the b value, which is just the number attached to the x, the plain x, so negative 3. Can you guys think of two numbers that would multiply to get negative 4, but the same two numbers would add to get negative 3? Perfect. Negative 4 and 1. Negative 4 plus 1. Okay, now here's the deal with this. If you've never seen the Berry method before, grab a paper for them real quick. Okay, you're good. Sorry, guys. Okay, now, the way this works, if you've never seen it before, you're going to take the very first term, which is 2x squared, drop the squared, and put that at the beginning of each of the factors. This is not going to be the answer, but this is the fastest way I have ever learned for how to get you there. Now, you fill in the factors with these two numbers that fit those requirements. So one was negative 4 and one was positive 1. It doesn't matter the order. Now, one or both of these, it's just one for this problem, is not the real factor. So to determine that, if the two terms inside your parentheses have something in common, that's not the real factor. So 2x and 4 are both divisible by 2. So it's just a trick to the method. You basically just disappear a 2 out of that. So the real factored form here, this would be x minus 2, and then 2x and 1 don't have anything in common, so that's the real factor. And I just do like a quick little spot check. If you take the first two terms and multiply x times 2x, that should give you back the first term here, which is 2x squared. And if you take the last two, negative 2 times 1, that should give you the term on the end. You could fully FOIL it out if you want to, but I usually just spot check those two. That should be your factored form there. So what I'm going to put on the top of this, x minus 2, 2x plus 1, and then I've got both in factored form. We're just going to see if anything matches. So x minus 2, x minus 2, nothing else is going to cancel out here. So 2x plus 1, x minus 9. Don't go, oh, I see an x in the top and bottom. It doesn't work that way. If you have adding or subtracting, it's over. So those guys are not products. We just have 2x plus 1 and x minus 9. Now, in terms of your restrictions, 9 here and 2 here. So x can't be 9, and then even though we canceled it out, it can't be 2 either, because it would make the original problem have a denominator of 0. That's the worst if you have to do a factoring of a quadratic that's got a number in front of the x squared. Is anybody having a question? Yeah. No, okay, it's only what's in the bottom. Only what's in the bottom. The top doesn't matter because you like I can take 0 divided by a number. I just can't divide a number into 0 parts. So it's only the bottom. You only have to worry about the bottom. That's an excellent question. You don't worry about the top of the fraction, only worry about the bottom. Okay, no, that's an excellent question. Only worried about the bottom. All right, now, this is pretty much just what we did. It's just like an extra step. So this is going to ask you to multiply these two fractions together and see basically what we can do to simplify this. Now, what I want to say to you, you don't need a common denominator to multiply for any of these questions. And if you know that, you don't have to write that down. But if you are multiplying fractions, you do not need a common denominator. So I don't have to create that here. So we're in good shape. We're just gonna, this is just like factoring on steroids. I'm gonna factor 4 different quadratics at the same time here. So none of these have a number in front of the x squared. So if I do the top of that first fraction, I gotta multiply to get 4 and add to get -5. Can you think of two numbers if you'd multiply them, you'd get +4, but you added them together, you'd get -5? Yes. Okay, in any order, one of them's x minus 4, one of them's x minus 1. Okay, on the bottom, I've got x squared plus 3x minus 28. So I would want to, each one of these factors is just going to start with a plain x, because x times x will give you back the x squared. So for the one on the bottom of the first fraction, I got to multiply to get -28 and add to get 3. Yes, ma'am. +7 and -4. Okay, now I'm going to leave this alone for the second. All right, the other fraction, the top of it, I've got x squared plus 2x minus 3. So on the top, I'd need to multiply to get -3. These are both, again, all of these guys are just going to start with an x because they just have an x squared at the beginning of each of those quadratics. Can you tell me for the top two numbers you'd multiply, get -3, same two numbers you'd add, and it would be 2. Perfect. One of them's a +3 and one of them's a -1. And then the last one, on the bottom of the second fraction, I got to multiply to get 21, add to get 10. 7 and 3. All right. Okay, now, what you can cross out is anything that matches top to bottom. All right, so if I have x minus 4, x minus 4, x plus 3, x plus 3, and then nothing else cancels. Like I have an x minus 1 in both of the fractions, but they're both in the top. So they only cancel if you have one on the top and one on the bottom. So I'm going to have both of those. So when I write my answer here, the top of this, I have x minus 1 twice. Just leave these in factored form for me. Don't FOIL this out. But since they're actually the same, we could just write it like x minus 1 squared if you wanted to do that, instead of writing it twice. But don't actually FOIL it out. I'm just going to have you guys leave all these answers in factored form. If you have anything where you'd have to FOIL or do something, just leave it in factored form. That just means leave it in the sets of parentheses. Now I kind of have the same thing on the bottom. These two are both the same. I have a 7 and 7. So you have exactly the same factor, so I can write that as x plus 7 squared. Now I got to go back through here, and even if we crossed it out, we have to exclude it. So here, -7, here, 4. Now this would be -7 again. You don't have to write it twice. And then the only other different factor I have in the denominator, x plus 3, so -3 would cause that to be 0. So 3 different restrictions on this question. And even if they cross out, you got to exclude them. So -7, 4, -3. You don't have to write those in any particular order, just as long as you have all 3 of them. And that would be my answer. A lot of this is just factoring. Does anybody have a question? Okay. Now, I know I had a difference of squares on one of the questions on the front. This one has 2 different difference of squares in the first fraction. So on the top, this one, all these factors are going to start with just the letter A. Trying to switch it up and put some variety in the notes today. We'll use a different letter on this one. Okay, on the top, I got to multiply to get -4, add to get 0. -2 and -2. So one's a +2, one's a -2. Doesn't matter which one goes first or second. Okay, now the bottom one always trips people up. But if I want to multiply to get -1 and add to get 0. Yeah, it's 1 and -1. It's the square root of the number. Like on the top, the 4, square root of 4 is 2. Square root of 1, it's its own square root. So that trips people up sometimes. So in this particular problem, nothing matches on the top or bottom for me to cancel. Okay, now I'm going to multiply that with, I just have this a plus 1. There's nothing to factor there. A and 1 don't have anything in common. I'm going to put parentheses around it because if we were to multiply together, we would just multiply straight across the top, right? So we're not going to do that, but we're just going to try and write this in factored form. Okay, now the bottom of that, this is not like a quadratic trinomial. This is just going to be a squared and 2a. So if it just has two terms and it's not a plain number, you're just looking for a greatest common factor. These guys both have a in them. So a would be a greatest common factor. I'm going to pull that out in front. Left over, this would be a plus 2. Now, when you are multiplying two fractions, you do not need a common denominator. So I'm literally just going to multiply straight across the top, straight across the bottom. So I'm just going to pretend this is all one big fraction. Now, if I notice anything that matches top and bottom, we can cross it out. So I know it's over here, but the a plus 1 here will cross out the a plus 1 here. And you have an a plus 2 here, and you have an a plus 2 over here. So even though they're in different fractions from the original problem, that all becomes one big fraction when you multiply, because you just multiply everything across the top, everything across the bottom. So if anything matches, top and bottom, you can cross it out. Now, everything else, they didn't have a match, so they're just left in the answer. So on the top, I just have a minus 2. You really don't need the parentheses anymore, because that's all that's left on the top. Now, what's left on the bottom here, I do just have an a right here, and then I also have this a minus 1. Typically, if you have just a plain number or a plain variable, you would write that first. So I would write a. I am going to leave this in factored form. So the other thing, I would multiply this if we were multiplying these fractions. I'm just going to ask you guys to leave it in factored form, which just means don't actually multiply that. Just go ahead and leave the parentheses. The reason I'm having you do that, when you have the parentheses, it's so much easier to see what your restrictions are. Okay, so now I'm just going to go back. Even if we crossed it out, we have to exclude anything that would make our denominator 0. So a plus 1, negative 1 would be a problem. A minus 1, positive 1 would be a problem. What number would be a problem for just a plain a? What, just 0. Yeah, if you just have a plain variable, 0. If I plugged in 0 right there, it'd be 0 times whatever. So that would make that 0. So you just have a plain variable at 0. And then a plus 2, negative 2 would cause you a problem if you plug that in. So this one actually has 4 restrictions. And it does not matter the order that you write these in, just as long as you have all 4 of them. All right, now the last one, probably the worst, because I have 1 on the bottom of that first fraction. Yeah, go ahead. No, okay, yeah, you don't have to, if it's in the top, you don't have to worry about it. So the only 2 that was in the bottom, this was a plus 2, so just negative 2. Don't even look at the top. It's just only what's in the bottom of the fraction that you have to worry about. Because 0 can be on the top. Totally fine. That's such a good question. Sure. No, we don't. Do you want one? I feel like we should have it Thursday, so that way you can focus on that instead of basketball. That was a joke. I was mean. I'm sorry. All right. Yeah, it's out for the next 2 weeks, right? Okay, so the top of this guy, difference of squares, x minus 3, x plus 3. I'm going to leave the bottom alone just for a second, because that's probably the hardest part of this problem. In the second fraction, both of those are just a greatest common factor. So this guy right here on the top of the second fraction, 5x squared and 2x, the only thing they have in common is an x. And then left over, you'd have 5x plus 2. So that's all I could do with that. Really similar on the bottom, I have x squared minus 3. Again, that's just a greatest common factor. Both of those terms are divisible by x. So I'm going to pull out in front an x. Left over, you'd have x minus 3. Now, the part of this problem I think is the trickiest is definitely this quadratic here. So I'm going to show you how to do that Berry method one more time. If you guys did like factor by grouping or a box, I am happy to show you how to do that if you want to remember that. I'm just going to do the Berry method for me because that's the easiest way I have ever learned how to do this. So you're going to multiply A times C and you're going to add to B when you do this. So A would be 5, C would be 6. So I got to find two numbers, multiply to get 30 and add to get 17. Can you think of two numbers that when you multiply them you'd get 30 and add them you'd get 17? Oh, go ahead. Which one? 2 and 15. Okay. Now, completely up to you. But what I do, you just take the first term, whatever that is, drop the squared, and put that at the beginning of both of your factors. One or both of these will not be correct. You fill in the factor with the two numbers we just said met those requirements. So one would be a +2, one would be a +15. Now, if it's the real factor, the two terms won't have anything in common. If it's like getting you there, but it's not the real factor, they'll have something in common. So this guy is not the real factor because both of those are divisible by 5. And it's just a trick to the method. You don't pull it out in front or anything. You literally just disappear it out. So this would be 5x plus 2. The real factor here would be x plus 3. And I always just do like a quick spot check from the original. So here's the original. 5x times x should give you the first term, that's 5x squared, and the 2 on the end, the 2 and the 3, those should multiply to give you the plain number. 2 times 3 is 6, so we should be good. So then I'm going to go ahead and just put that up here. 5x plus 2, x plus 3. Okay, now, this is one big multiplication problem. So if you want to think about this, this is just like one giant fraction, because we'd multiply straight across the top, straight across the bottom. Anything that matches, we can cross out. So here's an x minus 3, here's an x minus 3. Here's x plus 3, x plus 3. Here's an x and an x right here. And, ooh, actually this 5x plus 2, 5x plus 2. What will my answer be? 1. Like if you had 5 over 5, right? You wouldn't tell me 0, you'd tell me 1. It's like everything on the top matched everything on the bottom, so you're dividing something by itself, that's going to be equal to 1. That was not my intention, but apparently that's what happened. Okay, now, let me go back and do my restrictions. All right, if you got something complicated like this, think about setting this equal to 0, right? I've got 5x plus 2. So I would subtract 2 and divide by 5 if I set that equal to 0. I just kind of do that in my head. Or if you want to, you could say 5x plus 2, I do not want that to be equal to 0. You would subtract 2 and divide by 5. I just kind of do it in my head. It's up to you how you want to do it. X plus 3, negative 3 would be a problem there. Plain x, 0 is a problem. And x minus 3 would cause positive 3 to be a problem. So the answer is 1, but you still have restrictions here. X can't be the negative 2/5, negative 3, 0, or positive 3. Is anybody having a question?